Hello friends, my name is Sushil Pandey. Welcome to my networking video series. Today topic is network essential books and today I will be talk about network communication. In this part I will study comparing signaling methods and data transmission method. That's all. Let's start network communication.
Network communication. Communication on a computer network is enabled by different transmission media, such as wired and wireless transmission media. In addition, communication occurs when signals are transmitted from the sender to the receiver by different signal transmission methods. It is important for you as a network administrator to understand the different signals and signal transmission methods used to enable network communication. In addition, knowledge of media access methods will help you gain a deeper understanding of network communication. This knowledge will come in handy when you need to set up networks and suggest a proper signaling method for data transmission. This chapter describes the various types of signals and signal transmission methods used in a network. Comparing signaling methods. A signal is data transmitted in the form of electromagnetic waves over a network medium. For example, in your home, when you talk over the phone, your voice is transmitted to the other end in the form of electromagnetic waves. Similarly, in a computer network, the different devices communicate with each other by sending and receiving data in the form of electromagnetic waves. A network usually uses any of the two types of signaling methods, analog signaling and digital signaling. Understanding analog signals. An analog signal carries information as continuous electromagnetic waves. When computers are connected over a network, electrical current generates analog signals, the intensity of which is measured in volts. An analog signal oscillates between maximum and minimum values over time and can take any value between those limits. The maximum limit is known as crest and the minimum limit is known as trough. The size, shape, and other characteristics such as crest and trough of the waveform describe the analog signal and the information it carries. Understanding digital signals. Unlike an analog signal, a digital signal can have one of the two values 1 and 0 which represent the presence and absence of a signal, respectively. Every pulse in a digital signal represents one binary digit, or a bit. 8 bits represent a byte. Digital data, which is a sequence of ones and zeros, can be translated into a digital waveform. In computer systems and other digital devices, a waveform can switch between two voltage levels 0 at the ground, also called a zero voltage state, and 1 at a positive or negative voltage level. The following figure displays a digital signal. Identifying data transmission methods. Data transmission is the exchange of data among computers or other electronic devices connected over a network. Data transmission in a computer network occurs using a proper signaling method such as analog or digital signaling. In computer networks, data in the form of graphics, animation, audio, video, text, and emails is transmitted to other devices connected to the network. For example, you want to send an email message with an attachment. The email message will be first converted to binary bits, which are transmitted over the network as analog signals. At the receiving end, the analog signals are converted into digital signals. This Understanding unicast transmission. Unicast transmission is a method for data transfer from a specific source or host to a specific destination. Other network nodes that are not involved in the transfer ignore the transmission. Unicast transmission is the predominant mode of transmission on LANs and the Internet. The following figure displays unicast transmission over a network. Unicast transmission. Unicast transmission has the advantage is that it is faster because only two devices are involved in communication. As the size of the network increases, the network becomes slow. Understanding broadcast transmission. In broadcast transmission, one computer sends data to all other nodes on a network. Since the packet is broadcast across the network and all the nodes in the network simultaneously receive the packet, this kind of transmission generates huge traffic in large networks. Therefore, it is confined to small networks such as LANs that use Ethernet technology. Usually, servers in networks advertise their presence by sending a broadcast message. Understanding multicast transmission. In multicast transmission, a sending node can communicate simultaneously with a group of computers in a network. This group of computers is known as a multicast group. The group of computers that is not part of this multicast group ignores the data sent by the sending node. Most organizations create multicast groups to distribute specific data to specific groups. The following figure displays multicast transmission. Multicast transmission. Understanding serial data transmission. In serial data transmission, a single bit is transmitted over a transmission medium in sync with one clock cycle. In addition to data bits, the transmission medium also transmits synchronization bits, start/stop bits, and error correction bits. Keyboards, mouse devices, modems, and other devices use serial data transmission. In serial data transmission, data is transmitted as a series of bytes. To differentiate between bytes in a stream of data, the network uses two techniques: asynchronous communication and synchronous communication. Asynchronous communication. In asynchronous communication, the sending computer inserts special start and stop bit patterns between each byte of data. The receiving computer can identify data bytes by distinguishing these special bit patterns from the data stream. Synchronous communication. In synchronous communication, the sending computer sends bytes after a specific time interval. Understanding parallel data transmission. In parallel data transmission, multiple bits are transmitted over the transmission media. In this case, transmission media consists of multiple transmission lines. Other bits such as synchronization bits, start/stop bits, and error correction bits are not sent along with the data bits. These bits are sent over another transmission line. Printers and scanners use parallel data transmission. In addition, the system bus inside your PC, the small computer system interface, SCSI, data bus, and the PC card bus use parallel data communication. Understanding baseband transmission. In baseband transmissions, a single signal uses the entire bandwidth of the cable and the transmission medium can carry only a single signal. A baseband system can be used to transfer both digital as well as analog signals. The following figure displays baseband transmission. Baseband transmission. Understanding broadband transmission. In broadband transmission, analog signals are sent over the transmission medium. It uses the entire bandwidth of the transmission medium. High-speed internet communication uses the broadband transmission method. Broadband communication also allows transmission of multiple signals at the same time. The following figure displays broadband transmission. Identifying media access methods. A media access method refers to the method used by a computer or a device in a network gains control of the network media, such as cable, to send the data. If a proper media access method is not implemented, the data packets transmitted over the network media will collide with other data packets and consecutively be lost without reaching the destination. Media access methods are broadly classified into the following three types. Controlled media access, contention-based media access, token passing media access. Understanding controlled media access. In controlled, or deterministic, media access, a central device or system decides how long a node in a network can transmit data. For example, a node in a network needs to send data to another node. Before sending data, the sender node checks whether there is any activity in the central device. If a sender node detects activity, it waits. If there is no activity, the sender node transmits the data to the other node using the central device. The following figure displays controlled media access. Multiplexing. Multiplexing is a controlled media access method that uses a central device known as a multiplexer. A multiplexer receives signals from all. Understanding contention-based media access. In contention-based, or competitive, media access, the nodes in a network themselves decide a media access time. For example, in a network, two nodes need to send data. These nodes continuously try to send data until they succeed. If the data is lost in collisions with other data in the network, the nodes will resend the data. One of the main problems associated with the contention network is the understanding token passing media access. Token passing media access is one of the network transmission methods in which a frame, also known as a token, is passed around a network. This frame, token, is empty, and it circles around the network at a very high speed. When computers or devices want to send data, they wait for the token to be received. Once the token is received, computers or devices add their data and the destination address of the receiving device to the token.